So, good evening, class. Good evening, friends. So, first and foremost, we commit our ways unto God's hand. We want God to lead us and direct us. Now, before we'll be moving on physics today, checking on linear momentum. So, I hope you guys understood the lesson we treated last. That was measurement of it. So, today we'll be checking on this and linear momentum. So, this is force equals to changing in momentum over time. But how to prove this? So, we need to know the Newton's law of equation, Newton's law of motion. We need to know the first one, the second Newton's law of motion, and the third Newton's law of motion. So let's look into that. So looking at the first Newton's law of motion, states that every body continues in its state of rest or of uniform motion in a straight line unless compelled by some external force. So external force to act otherwise. Let's explain that. So, for instance, an object at rest. When, for instance, maybe the object is at rest. So, the first law states that this object at rest can still move. Can still move, maybe naturally. Just place an object on an inclined plane. You will notice that at rest it will, or on an ordinary ground, the object or a ball. So the ball will roll unless the ball is being kicked back to act otherwise. So that's the first rule. So the second rule states that the rate of change of momentum of a body is proportional to the applied force and take place in the direction in which the force acts. So so the second one, a force acts. Maybe for instance, the object is moving this way. Note that the object is in mass, is a mass. So for instance, the object is moving in this direction, and lo and behold, a force, maybe someone now kicked the ball. You will notice something, that the ball is moving towards this direction, but when someone now kicked the ball back, you will notice that it will move in this direction. So there is a change in momentum there. The mass with what? The mass is moving with speed. You must know that. So definitely you must know that the object initially is moving with some speed. So that is the initial speed. You can call it initial speed. But moving towards this direction when being kicked, that's the final velocity at whenever the ball stayed. We don't know that, but we want to prove this. So the force is proportional. It's proportional to the change in momentum over time. In time, from when the ball is being kicked, it takes some particular time to get to this point, to the final velocity. So this is the formula. You now say this, since this is proportional, so F equals to mv minus mu over time. So this is the formula. So that is how we got this. So let's move to the third law. The third law states that if whenever a force acts on one body, an equal and opposite force acts on some other body. Let's explain that. The third law states that when a force acts on this body, the force being acted on this body will be the force acting on this and moving in opposite direction and moving with the direction towards this direction of the object, moving towards this side. So the same force and opposite force. So let's move into some calculation on this, and let's go into it. Looking at this example 1, a net force of magnitude 0.6 acts on a body of mass 40 gram. Initially at rest, calculate the magnitude of the resulting acceleration. So let's look that.